All right, so today we're going to look at what are called time series graphs. And the first thing you need to know about a time series graph is it looks like one of the graphs that we've done before. This is just a specific type of line graph. And remember, we looked at line graphs, we had dots, and then we just connected the dots with a line. Remember those? Okay. So, all right. Okay. Now, not technically. Okay, so what we're going to do is we're going to talk about the features of these and talk about how to create them and how to look at them and read information from them. So they're called time series graphs because the scale on the bottom is always going to be some measure of time. Okay? And in order to make a time series graph, you must include the units. Okay? And then on the other axis, how you're going up, is just going to be whatever it is you're measuring. So let's say, for example, I was going to measure your height over time. Yeah? So I could do when you were 1, when you were 2, when you were 3, when you were 4, etc., and then on this scale, it would just be how tall you were. Okay? And again, make sure you put units there as well. So what's happening is it's going to measure your height over time. Did you always grow at exactly the same rate? No. Sometimes you grew faster than other times. Sometimes you might not have grown much at all, right? And so what happens here is you're going to get well, you probably didn't go down though, huh? You're going to get a series of dots for each piece of information, and these are then going to be connected with a line. And from looking at the line, we can tell some things about what's happening over time. And that's what time series graphs do. So we're just looking at what's happening over time. Okay, so we're going to look at a couple of these, and we're going to use Education Perfect because the drawings are really good and we can see pictures of what's happening. Now, be prepared. You will be asked to create and read a time series graph, right? So watch closely. It's very easy, but you need to use the right language. Again, remember, a big part of what we do in statistics is learn how to use the right language to describe things. Right? Like we don't just say the difference between the maximum and the minimum. We call it specifically we just went over it. Range. There you are. Right? So using the right terminology is important. Okay? So we're going to go really quickly through just how to read them and how they're created because we've done line graphs before. So most of this is not going to be new to you. Okay? So time series, again, are just a type of line graph that measures what's happening over time. So time is always your independent variable. Remember that when we talked about those, the independent variable is the thing that's driving it all. And in a time series, that means it's always the time, right? So we're measuring things over years or through the day or whatever. And then we have the dependent variable here, and it's dependent on the time. So, for example, go back to that one about your height. How tall you are depends on how old you were at the time, yes? Now, if you try it backwards, it doesn't work, does it? How old you are depends on how tall you are. That doesn't really make any sense, does it? So you can always tell which one to go with. But remember, in a time series, everything is always based on the time. Okay? All right. So we're going to look at how a few of these are done. So here's an example. They just give you one. We're going to learn how to read and construct them. All right. So again, as I mentioned, the time always goes on the bottom, and then the thing that you're measuring is always going to go up and down. So, and the measurements that you use for time can vary. You can use months, years, days, hours, right? For example, we could talk about how attentive you are at different times of the day. Yeah? We know when the bottom one would be, right? Period 6. 6. Yeah, we love period 6. So look at this one for example. We have years, first year, second year, third year, fourth year, and fifth year. So this one is just general years. It's not specific years. Could be specific. You could have like 2001, 2002, right? Depends on the data that you're measuring. So here they're just measuring the number of peaches that were picked in a certain year. On the first year, they picked 25 peaches. 25 peaches from his tree. On the second year, he got 40, and etc., right? So we're going to look at how this is put into a time series graph. So here we go. So first year, right, time goes in the bottom. Make sure you put years or months or whatever you're measuring. In the first year, he got 25, so that's halfway between 20 and 30. Okay? Second year, he got 40, so that's right there. And so we get a series of dots. Now, the series of dots tells us the data points, but it really doesn't help us determine what's really happening. So the next thing we will do is just connect all of those dots with lines. Okay? Now, so you're going to do a little bit of building these in this exercise. And now we're going to look at how to read data from them, because remember that when you answer questions from these, you need to be specific. Just saying that he picked more peaches every year is not enough, right? We need to know how many. And we need to know things like which year did he pick the most peaches. And we can't just say he picked the most peaches in the third year. We need to say he picked the most peaches in the third year because the number of peaches on that year was whatever, which is 10 more than he picked on the next year, right? Remember the descriptions, so the who, what, when, and where of it. Everything you do needs to be in a complete sentence. Okay? So here we go. We have some information here. We're not going to go through all of these, but what I can do is just pick a date and find out how tall this Jerry Giraffe was. So in year 4, how tall was he? About 350 centimeters, right? So he was about 350 centimeters in year 4. Okay? Now, you can't really say it's exactly 350, can you? No. Because it's not on a line. Now, how about this one, though? Would I say about here? No, he's exactly at 400. So be careful about your language, right? If you can't read it exactly on a line, then you say about or approximately, whichever word you like best, okay? Or it looks like, however you want to talk, right? It's your language. Okay, so I'm just going to read the point and for each individual parse. Now, look at some of the other things that you can see from this line graph. For example, here, he was growing pretty steadily, wasn't he? That looks like a very straight line. So that's a very steady amount of growth. Yeah? But here, what looks to be happening? Stayed the same. He didn't grow at all, did he? Okay? And if he didn't grow at all, you're going to find there's a word for that. We'll look at it in a moment when we do that. But then he started growing again. Yeah? So we can see what's happening over time. Now, this is a very simplified graph, right? And so you're going to see there's a lot more to it than these, but that's what we can get out of these, okay? Now, we're going to look at how we can then read information for these, and then we're going to look at those pieces of information that are most important. So, for Wax and Whisker, the most important things were range, interquartile range, and median. So now we're going to look at what's most important for line graphs. These are the two types of graphs that you're going to have to analyze on the assessment. Okay? And you're going to see them from now on in your mathematics career. So let's go to analyzing them. All right, so now we're going to look at analyzing these. And again, don't get carried away with these, but do use the right words. So most of what we're doing here is just trying to get you to look at things in a statistical way. Think of it in a very organized way. All right. So a couple of things that you're going to be looking for. You're going to be looking for the trend, and we're going to define each one of these in a moment, so you don't have to write them down now. We're going to look for the trend. We're going to look at seasonal and cyclical effects. Cyclical just means cycles. In other words, do you see something that's repeating, right? Okay? And then any unusual points, which we usually think of as outliers, right? They're just not like the others. Okay? So, and then we can then use the features we see in the time graph to make predictions based on that data. In other words, I might know what I've spent on my electric bill in 2021, and based on that, I want to see what I think I'll be spending in 2022, right? So we can look into the future based on what's happened in the past, okay? And we're going to learn how to do that. So, first thing we're going to look at are trends. Now, when you think about a trend simply means the overall direction. So we're not gonna pay attention to what's happening in the middle. We're kind of concerned with what's happening. So a while ago on that giraffe graph, sorry, couldn't resist. Okay, it started out down, and his height was going what? Up. So the general overall trend was that it was going up. Okay, keep it simple. All right, so we're going to look at a few of these. So the overall trend just means the direction of the graph. Mm-hmm.
You say it's going positive, you know, like...
Yes, and we'll talk about that exactly. Yes. Okay? Good job. So, got a couple of things, and now here's where I was going to tell you about those terms. So when you're describing the trends, we're going to use these terms. Increasing means it's going what? Up. It's getting bigger at each time, right? Decreasing means it's going down, right? So like the amount of ice cream that you have in the freezer. Right? And then here's the other word that might be new to you that I want you to really know, and that is constant. Yes, exactly. So like those 2 years where Jerry the giraffe did not grow at all, that was when his height stayed constant. So if I have a graph that's doing this, doesn't matter that it jumps up and down. It looks like it's going what? Up, so it is therefore what? Increasing. If I have a graph that's doing this, it's decreasing. If I have a graph that's doing this, it looks like it's staying pretty constant, right? Now, it doesn't stay completely flat the whole time, but does it look like it's gone up any at the end or down any? So what you're really comparing are these points at the end. Is this point higher than this point? Yes, it's increasing. Now, did it decrease in some points? You bet it did. But we're not worried about that. We're just worried about the ends when we're talking about a trend. Okay? So here, this end and this end looked pretty close together. You could say that it's slightly increasing just from my drawing, but really it stayed pretty constant, didn't it? You really need to have a big difference to say it's increasing. And it needs to be pretty flat to say it's constant. So those are the terms you're going to be using. And you may remember that if things are going up, we consider them to be positive. Going down, we consider them to be negative. But we need to use increasing, decreasing, and constant. Okay? So we're going to look at a couple of examples, and you're just going to define the trend. Okay? All right. Okay, here we go. We start off here. We end up here. So what is happening to the distance traveled by this pod of dolphins? What's the overall trend? It's decreasing. They're traveling less over time, aren't they? Now, even though in May they traveled a lot more, right? Overall, the trend is that it's decreasing. Make sense? So we're not interested in what's happening in the middle, only what's happening at the ends when we're discussing trend. Okay? And you'll see that they just drew a line from the beginning to the end so that you can easily see. This is called a trend line, and if you want to draw it, you can. You may be asked to draw it, and just draw a line from approximately from the beginning to the end. Now notice they're trying to get it as in the middle of all the data points as you can, and you can see that the overall trend is still downward. Okay? But you can just draw it from the first point to the end point. It sometimes doesn't collect all the data, but for our purpose it's fine for trying to get a trend line. Okay, here we go. What do you see? Increasing. Here it starts down here and it's go there. Does it have seasonal changes? Yeah. You see how uniform those hills are, that's a seasonal change. We'll talk about that in a minute. Okay? But you can see overall the trend is going upwards, so it's increasing. Okay? All right. Now, the next thing we want to talk about some seasonal effects. So let's get a definition of that. Now, seasonal effects, you have to be careful. Seasonal effects are regular short-term patterns. So the key there is regular. So, remember that graph a while ago? It went up, then it went down, and then it went up, and then it went down, then it went up, and it went down, right? These look very regular. Now, do they have to be identical to be the same? No, they just have to be following the same pattern, right? So this is what's called a seasonal effect. Okay? All right. Now, it's seasonal because it's based on a calendar year. So what happens to, you think, your heating bill in the wintertime?
It goes up.
What about in the summertime?
It goes down.
Right? Every summer and every winter?
Increase.
Yeah? So that's seasonal. And again, seasonal is based on the calendar year. Now, cyclical effects are the same type of thing, but they're just fluctuations over time. So it's not really, you're not really talking about how a specific calendar effect. Okay? So it's a little bit different, but they really are the same kind of idea. Yes? Pardon? Yes. Okay. Yep. Started yesterday. Okay. So we're going to look at some cyclical effects and how to explain them and how to talk about them. So here we go. Here's a time series. It shows weekly passenger numbers on a flight from Sydney to Auckland. So this is, if they're weekly time from on passengers, do you think the weather affects the number of passengers? We could say that there may be more travel at a certain season or something, but this one is really just a cyclical effect, right? But they mean the same thing. You're never going to be asked to determine is it seasonal or cyclical, but is there effect? What do you notice here? We notice that it goes down, goes up, goes down, right? Across the week. And if you look at this part, this week, doesn't it look a lot like this week? Which looks a lot like this week?
It's a seasonal effect.
Right, so something is happening over these weeks to make a pattern. Okay? So here we go. And when we're talking about it, we need to be very specific. Notice that the amount of flights goes up on Monday, goes down on what? Wednesday, and then goes really high on Friday. Right? There you go. People are going home, right, from work. So they're going to their work of Mondays and Tuesdays. Not so much on Wednesday because they usually where they're supposed to be, right? Then on Thursday and Friday they start going home. Yeah? And if this is business travel on the weekend, they're already at home. So you see it flops back down on Saturday and Sunday because those are just the people traveling for fun usually. All right? So there's a pattern for these. And notice that it repeats. Here again, up on Monday, down to Wednesday, back up on Thursday and Friday, back down for the weekend. So do you see that repeats every week? Yes. Yeah, they're the same. You read them the same way, right? It's just they're two different ones simply because some of them are due to weather or season, and some of them are just due to a cycle like time. Like this is just time, right? The work week is what's driving this, isn't it? Okay? All right. So look at this one. Here we go. We have the months at the bottom. We start off high at 450, and then what's happening? It's going decreasing till we get to, that's July down there. And then it starts what? Increasing back up, okay, to December. So what's happening here is that we have what looks like a pattern, but it's probably, it's changing over time, but this is probably due to the weather. So we're talking about the wind turbines churning, right? So what happens in some seasons? It's windier in some seasons than others. But if you look at this is just time series data for 1 year. Do you think it's always, can we look at this and say that it always dips in July? No. So this time, we don't have enough data to see that a pattern is happening. It looks like a pattern is happening. It looks like in the summer, there's more production, and in the winter, there's less. Yeah? But we can't really say that because we don't have enough information. Now, what if I had 5 years of data? Would I be able to look and see a trend then, possibly? Yes, if it happened over a long series. So be careful. Don't find patterns where they don't exist. Okay? All right? Have you ever had good days and bad days?
Yes.
Are they always the same day?
Yes, they're always bad days.
Come on, chill and focus with me a little bit. It's not a performance, guys. Come on. So, yeah, but they aren't always on the same day. And if I just followed you around for 1 week, all right? So I'm going to follow you around for 1 week, and I'm going to ask you, are you happy today or are you sad today? And then, or whatever emotion. Okay. So is it always, and I just take a week's worth of data. Well, could things have affected that week where you're particularly sad at the beginning, right? But happy in the end? Okay. So you can't really get an effect or say that there's a pattern if you don't have enough time. Okay. So there's not enough data to see any repeating patterns. Okay? All right. Unusual features. Remember, we talked about something like this. Outliers, exactly. So we're thinking about something that's unusual. So let's look at the graphs and see what that looks like. So far, we've looked at trends, increasing, decreasing, constant. There you go. That's a new word probably for most of you when you're analyzing these. And now we've looked for patterns, right? The last thing we're going to look at are unusual points. Now, you've got to be careful with this. They have to really be unusual points in order to be considered to be unusual, okay? So you can't just say, so here, if I look at this is the highest point in the whole graph, isn't it? But it's not an unusual point because it also goes up here, right? But look, if you look here, there's a sharp dip here. That one is unusual, looking at the rest of it. Now, we do have some dips, other dips down, right? But they're not as extreme as this one, are they? Okay? So, it has to be pretty extreme for you to call it an outlier. So don't go hunting for them where they don't exist. Okay? Now, when you're talking about this and you find an unusual point, you're not allowed just to say, well, there's an unusual point in between January and February. You also need to try. Now, you're not always going to have the background knowledge to do it, but you have to try to explain why it's happening. Right? Show some insight. So, when we think at this is the sleep patterns of baby seals. Do you know enough about baby seals to know why they slept less between January and February? No. Probably not, right? So, in this one, the best we would do is some kind of guess. Well, it's okay because it shows that we're trying to see what's happening. But in this case, we probably don't have enough knowledge, okay? Now, what about if I saw a huge dip in use of Education Perfect at 10:20 every day at Queen Margaret? What would happen? That's an unusual thing. It's because usually it's pretty constant throughout the day, but at that one time it really dips lower. What's happening? Morning tea, and you know that, so you would be able to address that situation, right? So we know that every day at 10:20 it's morning tea. Students are a lot more interested in sausage rolls than they are in doing their homework, right? Okay, or whatever it is you like to have. Okay? All right. Now, yes?
Unusual features practically also a name for outliers?
Yeah, it's the same thing. Mm-hmm. All right. One last thing. Come on, guys, and then we'll be done with these. We also can use time series data to make predictions about what's happening. So if you got taller over the years, what can you expect to happen?
Get taller more.
You should anticipate getting taller up to a certain point. Are you going to continue to grow forever? No, at some point you get lucky like me and you start to shrink. Yay! Okay, so now I'm not shrinking yet, but fun. All right, so we're going to look at how to make predictions. Ladies, come on now. You have to be very careful when you're making predictions. So we can make predictions, but when we do, we don't just consider the overall trend. We also have to consider any seasonal effects, right? Because if you see that over time, this thing didn't increase at this point, it went down, then that's the prediction you need to make. So be careful. The only way you can be able to tell and be confident about your prediction is to consider everything. Okay, shh, ladies. All right. So here we go. A crop farmer is analyzing their harvest data from 2010 to 2015, and they want to predict how much seed they will harvest in the coming year. Using the data from the time series, draw the predicted harvest on the graph and comment on how confident we are. So here we go. Here we have our time series, and you notice that it goes up, then what?
Down.
Up and down, up and down, up and down, up and down. Does it look like there's a pattern?
Yeah.
Yes. And it's probably a seasonal change, yeah? Because usually plant at one time. So like here, he's not harvesting much, but he's harvesting a lot in the fall. Doesn't harvest much in the winter. Harvests a lot, right? Up and down during the seasons. If you know about farming, then plants are growing over the summertime. You harvest them in the fall. Then less in the winter, harvest in the spring, right? So you have a winter crop. Okay? So, and we can be pretty confident that pattern is going to hold because it's continuing over several years here, right? We have enough data over years. But what do you notice is the overall trend for his harvests?
It's going downward.
Yeah, this one is decreasing, right? It's very slight, but it is decreasing. So his harvests are decreasing over the years, but not always at the same rate, okay? So we can continue and look at 2016 based on what's happening. So you see that we drew a spike in August, down, and then up again in spring, or autumn, I'm sorry. Up in autumn, down in winter, up in spring, and then down a little lower. And they continued that downward cycle. So it's a tiny bit lower than the year before, because that's what's happening over time. So we can predict what's happening in the future based on what's happened in the past, right? But be careful with it. It's still going to maintain that same seasonal pattern, most likely. Now, does it have to? No. Now he could decide that he's going to spend his winters in Bermuda or something, so he doesn't have to plan anything. So it doesn't have to, but most likely it will, right? Good job. So, okay, you just have to make sure that you don't ever say that you know what's going to happen. You can say, though, I clicked it too fast. We can say we are confident. We can be pretty sure of, or reasonably confident, whatever language you want to use. But we can be confident based on what happened in the past, but you can absolutely not say this is what will happen. Okay? So be careful when you're making your predictions. All right, so I'm going to get you an assignment here. We're going to have 2 assignments. You're going to be working on building some of these, and then you're going to work on analyzing some of them, reading data from them. Pay particular attention to analyzing them. Then, remember that we will still meet again this week. And our test, we have a short week next week, right? And so our assessment on this is going to be next Friday. I can't tell you enough. I am happy to meet with you at lunchtimes or after school if you let me know you're coming, to help you if you need help on any of these things beforehand. Now we're going to do some kind of practice. I don't know what it's going to be, but we'll do some kind of practice this week before we leave for the long weekend. Okay? Just one second.